Year 13, this is the walk through question 4. So figure 2 shows a sketch of part of the curve of y equals f of x, where x is real, where f of x is 2x minus 5 whole squared, brackets x plus 3. Before we kind of get on to the questions, just a note about this. They've put it in brackets, hopefully so that you start to kind of think about why they might have done that. If it's in brackets, what you can then figure out are your roots. So remember that at the minute, x plus 3 would give us a root of x equals minus 3, which is going to be that point there, isn't it? And this other root would give us a value of x is 5 over 2. So that's going to be x is 5 over 2 there. Okay, so those are the kind of things that whenever you get something like this, you need to start thinking of why have they given me it in brackets? They've given me it in brackets because they give me the roots of the equation straight away. Okay. Part A, given that the curve with equation y equals f of x minus k passes through the origin, find the value of the constant k. Now this time, when it's like that, outside the bracket, it means that it is looking at where it's going to affect up and down. It's looking at the y values, isn't it? So a minus k will shift this thing down. So where is it going to go through the origin if this thing is pushed down? Well, it's going to basically push it from there down to there, isn't it? So I need to figure out what that coordinate is there. What is the y-intercept of this curve? And then I know that if I'm taking away that number, it will shift it from there down to there. So I need to basically just figure out what the y intercept is there. Now you've got a couple of ways you can do that. You can either multiply it all out and obviously it'll just tell you what the y-intercept is at the end, or you can just sub in x equals 0, because remember for the y-axis that means that x equals 0. Okay, I'm going to multiply it all out because you are going to use that later on. So part AI, f of x will equal, if I multiply that out, I'm going to get 4x squared. Remember that when you're multiplying out brackets squared, square the first thing, multiply the two things together and double it. So 2x times minus 5 is minus 10, doubled is minus 20x, and then square the last thing, which is plus 25, and I'm going to multiply all of that by x plus 3. And then we need to times each of these things by x, and then each of these things by 3. So I'm going to get 4x cubed minus 20x squared plus 25x plus 12x squared minus 60x plus 75. So just grouping them together that quickly. 4x cubed, there's your x squared, there's your x squared, that's going to be minus 8x squared plus 25x minus 60x is going to be minus 35x plus 75. So at the minute, the thing will be going through 75 on the y-intercept, which means that k must be 75, because to shift it from there down to there, we'd need to take away 75 after f of x. Okay, right, part A2. The curve with equation y equals f of x plus c has a minimum point at the origin. Now remember that when you get plus c, find the value of the constant c, sorry. When you get plus c, that means a translation left. Remember, it's inside the bracket, it does the opposite of what you'd imagine. Plus c, if you're talking about the x direction, we'd imagine the positives will go that way. Because it's inside the bracket, it works the opposite way, it goes left. Has a minimum point at the origin. Well, there's the minimum point at the minute. So I want this shift to go like that. So what was that value at the start? Well, we spoke about that, wasn't it? That must come from the roots at the start. So the roots were 5 over 2 and minus 3. So that one has got to be 5 over 2. So if I add 5 over 2 into there, it will shift it left so that it comes through the origin. So for part A2, C is 5 over 2. Okay. Now, a lot of that is just remembering certain things about graphs, obviously applying it back to transformations of graphs, which I know are tricky and hard, but there's not too much difficult maths involved there. I mean, you didn't need that if you didn't want to, because I figured out that k was 75 by just subbing x equals 0 into there, so effectively a minus 5 squared times 3 would have given you the 75 there. Right, part B then. So because I've already multiplied the f of x out there, I know that f of x equals 4x cubed minus 8x squared minus 35x plus 75. So f dash of x, remember, means differentiating. So times by the power decrease the power by 1. So 4 times 3 is going to be 12x, and this goes down to squared. Minus 8 times 2 is minus 16. The x power decreases to 1, so it's just 16x. And that x goes, it's minus 35. Right, part C. Points A and B are distinct points that lie on the curve y equals f of x. The gradient of the curve at A is equal to the gradient of the curve at B. That's really important. Given that point A has x coordinate 3, find x coordinate of B. So what I'm going to do here is we're going to use the fact that we know that A has x coordinate 3. And then if I know that the gradient at A, when x is 3, is equal to the gradient at B, it means that if I sub in 3 to my differential, it will tell me what the gradient is at A. I can then set the differential equal to that because I know that's the same at B, and then I can solve to figure out what x must be at B. So we've got your differential down here. I think that's why they say show that the differential is this instead of just calculating it there, so that even if you can't do that bit, you can go on and do the next bit. So what we're going to do is we're going to do f dash of 3, so sub in 3 to this. I'm going to do all this on my calculator just in case I make any silly mistakes. Times 3 squared minus 16 times 3 minus 35. So that gives me that the gradient is 25. Okay, so I now know that that must be the gradient at B as well. So if I now set f dash of x equal to that, and solve this, it will tell me what x is at B. Okay, so to solve this, remember, bring this over to the side, so we're going to get 12x squared minus 16x minus 60 equals 0, and then I'm just going to use the calculator to solve that. So I get that x is 3. And I get that x equals minus 5 over 3. So I've got two answers there. So which one is your answer at B? Well, I already know that one of the answers was 3 from there, don't I? I'm told that in the question. So just sort of make sure that is your answer there. Okay, x equals minus 5 over 3.